Okay. Well, we're talking about tapping and dying is what we're left with. And not the kind of dying where you die, but the kind that goes along with tapping. Okay, so where I left off was we were talking about the method. How do you actually tap something or cut the threads in something? So one, use the tap chart, which we covered, to determine the correct size hole to drill. So we're going to drill the right size hole. That's an R. D-R-I-L-L. There we go. Then what comes next? Drill it. Oops.
No.
Drill it with the D. Drill it. Drill it. Drill the hole. So for doing something in aluminum, what size drill bit? So we've selected the size drill bit. What's the included angle of that drill bit going to look like?
118.
About 118 degrees. Medium pressure, hard pressure, light pressure?
Medium.
Medium. Okay, hey, you guys remember some stuff. All right, so we drill the hole. What comes after drilling the hole? Right after that? Deburr it. Deburr it. Why am I getting stuff in lab that has bad edges and stuff? Oh, that's not good. All right.
People trying to do shortcuts.
All right, so use okay, what kind of tap am I going to use for my initial cut? There are three choices. Taper tap. All right, taper.
Taper.
Use a taper tap for initial cut. For initial tap or cut. In doing that, what kind of precautions do we need to take?
Make sure it's straight.
Very good. Make sure it's straight. What else?
Oil it.
Oil it. Lubricate well. All right, so we had this discussion for all of my second semester people. When it comes to engines, when I say lubricate something, don't act like you're paying for the oil yourself. Act like you get paid to use oil. Yeah, yes.
If you're slipping and falling as you walk by, then you're using just enough.
Yes, pretty much, yeah. If James comes to me and says that, complains because you're using too much oil, chances are you're using half as much as I wanted you to. So when I say, yeah, lubricate well, lots and lots and lots of oil.
Kevin, is this supposed to be used a taper tap for the initial?
Yes. All right, so we're going to lubricate well. What can we lubricate with?
Oil. Cutting oil.
Okay, cutting oil. So cutting oil.
WD-40.
Cutting oil. WD-40 with your tap and die. What is it I talked about I really like using yesterday? Beeswax.
Mind your own.
Beeswax. So there's actually some beeswax in there, and I use it.
Kerosene.
Yeah, kerosene. Anything.
Did you say that or did Phil say that?
Kerosene, maybe Phil, but it does work. There's specific cutting oil. If you don't have cutting oil, the very next thing I go to would be motor oil. If you don't have motor oil, or sometimes like beeswax over everything. Cooking oil, olive oil, yeah, whatever. No, use the right stuff. This is gonna be a hard one for you. Do not force. Okay, you gotta let it cut its own. Let the tool do the work. So, and you know you have to go about 1/2 to 3/4 of a turn, and then back it off. I don't want to just throw out numbers. What happens is as you're cutting the threads, if you just keep going, what happens is it starts to build up the material that it's taken out. And it actually starts to cut even deeper than it's supposed to. It's kind of like when you get a little hangnail on your finger here and you pull it. If you kept pulling it, it goes deeper and deeper. It's the same thing, right? Shrey's making like a face. Ooh. So I feel like it kind of does the same thing with the tap. So what you want to do is you go forward till it gets a little stiff, and then turn it until it breaks off the pieces. So, you can feel it, and that's what you're looking for. So it's not even that I do like, it's got to clock it, so it's 1/2, then quarter back, then 1/2, then a quarter back. I actually just feel it, and go with what the feeling is. So, if we stay with what Phil said, it's usually about 1/2 forward. Isn't that what he said?
Yeah.
And 1/4 back. I actually wrote 1/2 to 3/4 forward and about 1/2 back, so it depends on how far you go. All right. So that breaks off the chips and actually keeps it from cutting too deep in there. Because if you start to get material built up in the tap, then that material adds to the tap and it cuts it even deeper. Repeat. Repeat with bottoming, with the plug or bottoming as needed. Bottoming tap as needed. If you are cutting pipe threads, we got to think about something here. The more you go into a hole with a pipe thread, or even on a rod, what's going to happen the more you go? It's going to get more and more in that taper. So if you are cutting pipe threads, what do I want to say? Stop. When the ID, what's ID stand for?
Interdimension.
Inside diameter is correct. Because the deeper you go, the wider the hole gets. And then you get all kinds of problems. All right, the dies. They can be fixed or adjustable. You guys have the unfortunate luxury of working with the adjustable, and you can adjust them far too much. When you're adjusting it and you're getting close to what you want to do, you almost just look at the screw. I mean, just kind of scare it with a screwdriver, and that's almost enough sometimes. Don't think that if you give it a 16th of a turn on one side, you got to go give it a 16th on the other to balance it. It's okay if they're offset just a little bit. Just do one side at a time when you're getting really close. If adjustable, start at the wide position. Start at the wide position. And then if the threads are too tight, then recut it. Like that. If threads are too tight, and what class thread are we looking for?
3.
Class 3. And class 3, does that mean I'm going to need a wrench, or can I do it by fingers? Okay. By fingers. If threads are too tight, recut. With smaller setting. And repeat. Same thing. We're going to go 1/2 to 3/4 forward. And 1/4 to 1/2 back. Same rule. Lots of oil. Use plenty of lubricant. Lube. Those are our taps. What kind of tap do you... Oops, you can't see that because it's behind the picture. So let's move on. There we go. There's our adjustables. Move stuff around so we can see it. Okay, this is the one that you're using. Notice too that on these taps there's a side that you start it with and a side that you finish with. Sometimes it's very subtle, but there should be quite a taper going into it, and that's where you start. It helps you start it, and the other end will be very flat. These are my favorite right here. I like these because it's only got one screw, and usually that screw kind of stays put, and for the most part, you can almost, once you get them set, you can pull them out of your toolbox, and they're kind of already set for a class 3. These slide around and move too much. Fixed or just fixed. All right, thread repair. You liked that project? Well, let me tell you something. When you get to engines, especially if you work on older engines, I would say the major difference between a really good engine mechanic and somebody who's not, other than the fact that you just have a lot, you care a lot. But what, in my shop, what made somebody great at working in the engine shop, machine shop, is somebody who could deal with removing studs and fixing holes. You can remove studs and plugs without damaging the case, then you don't have to fix the threads. If you can't, then you have to fix the threads. So you have to be good at both of them. And a lot of times these old engines, they're just tired. And you torque something up, and you guys had that problem, right? You put the accessory case. It's always the accessory case. You're almost done. Accessory case goes on. You're putting accessories on. You put a bolt in. You're torquing it to 96 inch-pounds. You're getting it up there. It's 80, 85, 86, 87, 88, 88, 88, 86, 85, 84, 83, 86. Right? And it's just, dang it. And it's nothing you did wrong. It's just they're old engines, and it gets even worse when you work on old engines that have magnesium cases. Magnesium's the worst. It's soft. Really nicely produced parts these days come right out of the factory with helicoil inserts in them. A helicoil insert is better than the original thread. So if you think about just taking a block of aluminum or block of magnesium, which is even softer, and cutting some threads in it, and over the years you're running a bolt in and out and in and out and in and out, what happens to those aluminum or magnesium threads? They just start wearing out, right? And if you put a helicoil insert, one of these helicoil inserts, this is stainless steel.
Oh, okay.
All right, so now you've got stainless steel where your steel bolt is riding in and out of the stainless steel nonstop. So it lasts a whole lot longer. And when if something goes wrong with the helicoil, hopefully you can just put it out and put a new one in, although that rarely does happen.
Is it major repair or major alteration?
It is not a major repair or alteration. Now you have to be careful because it's one of these situations where it is a repair. And if you don't have the data to back it up, then you shouldn't be doing it. So for example, you're working on an engine and you pull some threads out, and it happens all the time. And so you think, well, I'm just going to helicoil it. Well, there should be something in the manual somewhere that says if threads are pulled, you should use a helicoil type insert. If you've got nothing, then I want to say somebody could come back at you and say, you broke the engine, you did an unauthorized repair, you owe me a new engine. So just be cautious. Know what you're doing. Know where your data is, because that's the kind of thing that happens. Even though this is an industry accepted practice, it's in 4313. So, but just be careful. Now, I suppose if I were working on an engine and that happened, because it's going to happen, I thought, well, okay, I'm just going to whip out my helicoil. But first, I'm going to make sure that it's legal on this particular engine, and I look, and it says nothing. It's completely and totally silent, not one word about repairing the threads. Now what do? Okay, AC 4313, is that approved data?
No, acceptable.
Acceptable data. So now you've got something at least to say, well, it's acceptable, it's an industry practice, it's in this FAA book, and I did it in accordance with that. It's just a minor repair. If you look that up and it says, if threads come out, you need to weld repair and retap, then what do? Then you can't helicoil it. So, and keep in mind, some of this stuff changes from time to time, but otherwise, these are actually very useful and make it stronger and better than it was before. Yeah.
What are the options to take a broken bolt, let's say, from the block?
You got a broken bolt. Yep, your day just got bad. Okay.
Yeah, but what is, can you use, well, the out is one of the options.
Yeah, that's one of those things where, okay, so the manual's probably not going to say, I've never seen a manual that says if you break a bolt, this is how you get it out. It's just one of those things you do. Right? It's just part of being a mechanic. And when you break a bolt off, your day got bad. There's only one way it's going to get a whole lot worse, and that's if you break the tap off inside the bolt. That's hardened steel.
Yeah.
chances are you're not going to get it out without ruining the part. At that point, your life is just go back home, go to bed. It's start all over.
What about using these on high pressure components or areas like spark plug holes or
Aircraft cylinders
Yeah.
come from the factory with these already in it.
really?
Yes.
Okay.
Yep. Right out of the factory. They're cut, helicoiled, and boom, brand new cylinder with a helicoil.
These they don't tend to vibrate out for any reason.
Oh gosh,
or-
no. Nope.
Okay.
They're excellent. Well, once the spark plug is in, it's putting tension on it, and so it's pulling it in place. That's my next thing.
What if
Oh,
you-
it's a little video, I think. All right.
What if you need to renew threads in the spark plug holes?
It's in the repair manual actually how to do it.
Okay.
All the new manufacturers that I know of tell you exactly what to do if you. Because every now and then the helicoil will seize onto the spark plug, and you pull out the spark plug and like, well, those are funny looking threads. And so you got to put a new helicoil in. It's in the repair manual. It's not a problem. All right, so thread repair. All right, so helicoil is actually probably a trade name. Helicoil uses a special size tap. So you have to buy the right tap from the helical company that comes in a little kit. So you get this special size tap and stainless steel spiral wound or wound springs to repair threads. Okay, so it's a special tap, and let me see. I don't want to go there. What the heck? And right on the tap, it's going to tell you exactly what size drill bit. So it's not on a chart usually anywhere. It might be in the kit you open up, and it'll have like, for this. But otherwise, it's always printed right on the tap. But here's a little trick I learned from a guy who did a lot of old engines. And so what happens, you've got an engine or something, and sure, you're tightening it up, and you strip out a thread. And you're like, oh, okay, that really stinks. Because you usually have to take apart everything you just did to get to the hole that the threads are going into. And so I had, done that, and I'm used to doing helicoils. And so what do? I grab my tap, and it says right on there, you need this size drill bit. I grab that size drill bit. I chuck it up and get ready to go. He goes, what are you doing? I said, well, I'm going to drill the hole that says on the thing. He says, don't do that. Because what you're going to do is the chances of you drilling that hole exactly, perfectly, square, straight up and down, or whatever, 90 degrees, is almost non-existent by hand. He goes, so don't do that. He goes, all you're going to do is make a crooked hole. Right now, the hole is straight and it's stripped. He said, chances are, if you stripped out those threads, the hole that you need to drill is very close to where it's supposed to be. And if you stripped out the threads, chances are the material that you're working with is soft enough that you don't need to drill it. He goes, just don't. He goes, just try it without. So, okay. So from that point on, he was right. It's 99 times out of 100. If you're working with aluminum or magnesium, don't drill a hole. Just tap it. Now, you have to be very careful because you break a tap off, you're going to wish you had never showed up for work that day because, again, it's hardened steel. You're not going to get it out. You just ruined the part. So you have to be very careful. It takes a little more tension. So you have to be really diligent about, I use a lot of beeswax. I'll clean it off a lot of lubricant. And just because I say go a half and then back a quarter, don't do it. Sometimes you're going to go an eighth and back a little bit. But you can feel it. Just do it by feel. Don't stress out the tap. And like I said, 99 times out of 100, you'll have a very nice repair going on there. So just got to use your head on that one. But just keep that in mind that a lot of times you can get away with it because the hole is already almost that exact
You
size.
mean tapping it up to the helicoil or tapping it to its original thread?
Oh no, you're not going to tap it to original threads. Original threads are gone. So it's the helicoil process. So the correct helicoil process is, okay, you stripped out the threads, you grab the right tap, look at the tap, see the right drill bit, get the drill bit, drill it. I'm saying don't drill it. See if you can put the tap through without. No. Dirty dozen? Why is that?
Norms. Number 12, norms.
It's not a norm. It's
It's a secret. Science.
yeah. It's just. I'm telling you right now
Well,
that
30
he was
seconds.
right. When you pull the threads out, the hole that's left, guess how big it is? It's dang near the same size. So, or do it your way. Okay. Let me see. So, but I'm going to write this: drill out. Now, this is a part that you can easily get a fixture and put it in a drill press and do it and you know you're drilling straight. Then I would just go right for the drill. I wouldn't worry about it because then you're doing it absolutely correct. But I'm telling you, when you're working on something that's not capable of going into a drill press and you have to do it by hand, chances are you're going to screw it up pretty bad if you don't. If you try and drill it, drill out strip threads. With drill specified in helicoil kit. / on tap. Tap hole with the special tap. Also, I don't have it in writing here, but my memory is the helicoil also makes the same type of taper taps. You have a bottoming tap because you're doing this a lot in blind holes. So you need to get the tap all the way down to the bottom. So you're going to have bottoming taps, taper taps, and everything else.
Where
Insert.
do you get all the stuff out of the bottom of the hole? Do you drop air?
I do, yeah. Drape everything in a towel. Well, if it's an engine I'm working on that's somewhat put together, I'll drape everything in a towel like you're doing surgery, and then use a vacuum to get down in there. Normally I would use beeswax anyway. So beeswax, the way I use beeswax is I'm going to literally pack this thing, all of the flutes here, completely pack it in beeswax, every single one of them. And then also pack all of the threads are packed in beeswax. The whole thing just packs all in beeswax.
Where do you get that much beeswax?
It's you.
From bees.
They have this drug.
Okay, so actually the best place to get beeswax is when you look at doing fabric on an aircraft. When you're recovering an aircraft with fabric, one of the components that you use for rib lacing cord is beeswax. So quite literally, the beeswax that we have in the tool room, I can recognize the color striping on it came from polyfiber. So it's for rib lacing. So it's not bad. So anyway, pack that all with beeswax. Then when I start tapping, guess where all the shavings go? They get packed right inside the beeswax right in here. So there's very, very little left in the engine. If it's a blind hole, I'll just use a vacuum and vacuum it out, and then I'll drape it, and then just hit it with some air and blow whatever's left out. And it's completely clean and lubricated. All right, we have this tool, which is the insert tool. Sometimes you can do it with just this tool, and there's also, I don't think I have a picture of one. There's also a second part of it that's optional, where you actually kind of load it like a little 22 shotgun or something. 22 shotgun, yes, because they make such a thing. 22 rifle. You got to put the little bullet in there. Okay, so you put the little, if you don't know what I'm talking about, it's okay. So you put the little helicoil insert in there, then you got to run this black tool up in there, and it catches it, and it stretches it out, makes it the right size, and then you put it over your hole, and then when you turn it, it kind of goes in different. But that's an option you don't necessarily need to do. Just like the 22 shotgun is an option. Not a lot of people own one.
Actually, they make rattlesnake shots.
I've seen those. Yes.
they have-
Thank you for yes. That's what I meant all along.
Yep,
So,
exactly.
Do they really make those in 22 though?
yes,
Yeah,
they
they
do.
do.
Do they really?
Yeah.
There's like little projectile. It's like little BBs and everything.
I know the rattlesnake are like a 22.
Yeah, it's 22.
Come on.
22 long.
All right. Then once the helicoil is in, you're going to break off the tang. Break off the tang. Oh, how far should the helicoil go into? You want to make sure that that last coil of the helicoil is actually really embedded in there and not going to pop out. Because they will. If you barely put it in there and it's not engaged in a thread, it'll pop out. So what can I write very quickly there? No, I just told you, so that's it. Write whatever you want. Break off the tang. If it's a bottom blind hole and that tang goes all the way to the bottom, you leave it in there. Unless it's big enough that you can get in there with a pair of pliers and snap it off and take it out. Otherwise, I'll just leave it in there. It's not going anywhere. Can't get it out. So, okay, this is something I don't necessarily like to say. I've said it a couple times, so I'll just, repair is as good, if not better, than original threads.
That's mainly from the size difference, correct?
What?
That's mainly from the size difference of the helicoil?
The science do?
Size, from being stronger?
No, it's because you've taken aluminum, steel on aluminum, to steel on stainless steel, running in and out. What's the problem with the statement, repairs is as good, if not better, than the original?
Can't really make it better than the
If you
original.
do it wrong, it's not gonna be as good as or better.
If you make something better than the original, have I repaired it or have I altered it? Or both. So now I've altered something. So, and I just bring this up because there used to be this thing all the time, especially in sheet metal, where somebody would do a sheet metal repair and say, that's stronger than the original. Okay, you can't do that. It's supposed to be exactly like the original. I've heard instances where people, especially on wing carry-through spars, working on wood and stuff, I think there was a case where somebody that I'd heard of that really made me think about that. So the carry-through spar is on aircraft without struts, so it can be a high wing or low wing. Usually low wing, they have a carry-through spar, which carries the weight of the wings going all the way through, and there's no strut helping it, like a Cessna has the struts or some of them. So somebody was working on one and developed, the carry-through developed some sort of crack. And so what they did is they just reinforced the snot out of it. And, step back, said, that is better than the original. And the plane flew for a couple hours before the wing just completely snapped off. And the reason why was because the carry-through spar was engineered to flex. And so this guy made it better than the original, took out all of the flex, so it didn't flex, it just snapped off. And with one wing, it just kind of flies around in a short circle until it doesn't. So it has become a bad thing in aviation to say better than the original. So that's why I have a problem saying that. But the truth is, in this case, if you look at higher end components when they're built out of metal, higher end components that are made out of soft metals, they come from the factory with helicoils in it. So like I said, cylinders are aluminum heads. They have helicoils right where the spark plugs are going to go. They do it right then and there because they know the aluminum's not going to hold up. So, but that's labor intensive. So it doesn't get done. But this isn't. But there it is. That's just the facts. So, yeah, that's my next point. I'm not going to write it all out. Some manufacturers install helicoils into soft metals like aluminum and magnesium during the manufacturing process, just to keep you from having to do it later. So you're going to do it now or you're going to do it later. That's the way it's going to work. Oh, and I think I have a short video. I know, yay.
Said you can take the helicoil out.
Yeah, you can take a helicoil out. It's not easy to do if you don't have the time. Okay, how do you do it? Well, first of all, you shouldn't need to take a helicoil out unless there's something wrong with it. And what sometimes goes wrong with it is people cross-thread bolts in and they grab one of the springs and pull it out a little bit. So now it's kind of, part of it's in there crooked and part of it's not. Well, once it's in there a little bit crooked, reach in there with a pair of needle nose pliers and just untwist it. You just pull it out and it kind of becomes a long string. Otherwise, you don't need to take it out. All right, can I do this without messing with my video? Let's see.
This video is presented by NewMetalWorker.com. If you work with metal long enough, sooner or later you're going to have to deal with damaged threads. Because thread repair is a problem in the industrial world, there's some pretty good off-the-shelf solutions for this problem. First, we'll look at fixing an outside thread, like on a bolt. Damaged threads like this may not look bad, but they can stop a nut in its tracks. And if you try fixing this by just running a nut down over it,
I broke it.
much better.
Okay, so that's something I didn't talk about, but in addition to what he's doing, he said, okay, you can just run a nut down over it, but he's going to pull out a die here. There's an alternative in between that, which is thread files and thread chasers. So that's something I keep in my toolbox, is a set of thread chasers. And what they are, it's hardened steel bolts and hardened steel nuts that are designed to go over slightly damaged threads to repair them. So like I have a set of fine thread and a set of coarse threads. So the fine thread nuts, like I will pull one out and it's like made for a 7/16. But the funny thing about it is it takes a different size wrench so you can identify it. So later you're like trying to assemble something and how come this one takes a bigger wrench? It's because it's my thread chaser, you idiot. So give it back. I wonder where that went. So thread chasers and we have a whole set of thread chasers. There's thread files, which gosh, I could go on and on.
The way is to run the right size die over those threads and clean up the expanded parts. One of the more common die-related questions is which side of the die starts out on the bolt. Notice how the cutting teeth on this die taper back to nothing. This is the bottom part of the die that goes over the bolt to begin the cuts. You just set that opening over the bolt, hold everything level, and start turning it slowly to let it engage the threads. There's several good threads above the damaged ones that'll let us get this die aligned and started properly. The die will start to show some resistance when it encounters the damaged threads. At that point, you want to start turning the die forward about 1/2 to 3/4 of a turn, then back it up about 1/2 a turn to break the chips, and keep repeating that cycle.
Finally.
Even though this is light cutting, I still add a little bit of oil just to make sure everything goes smoothly. Then after we've cut through the damaged threads, I'll go ahead and run the die up and down the bolt a couple of times just to make sure it's cleaned everything up well. After cleaning it up with the die, we can still see some very small flat spots on the ends of the threads. As small as those flat spots are, they're not going to cause us any problems, and you can see that the bolt threads right into the hole with just my fingers. If this bolt is going to get a lot of stress, I would still get a new bolt and install that as soon as I could, but this will work for now. When we strip the threads out of the inside of a hole, things can get a little more complicated. Sometimes you can just drill the stripped hole out and thread it for a larger fastener. But that's not always possible. A lot of times the piece that the bolt goes through that is holding on can't handle a larger fastener. We also have to be careful of what's around the hole that we're working with. If this was a whole cylinder head on a real racing engine, this would be a real big problem. For many thread repairs, Healy coils are worth their weight in gold. These little inserts let you drill out the bad threads, screw these in, and come up with the same threads that are in there before we strip them out. And they make these inserts in all of the metric and standard inch thread designs and sizes. These single thread kits come with several inserts, an installation tool, and the tap you need for screwing this insert in. Everything in these Healy coil kits is very well made, from the tabs to the insertion tool. But these little coils is where the real genius is with this system. The coils are made from tightly wound diamond-shaped wire. This tang on the end is engaged by the insertion tool and actually turns the insert in. And you can see the little notch next to the tang in the wire, and that's for snapping this tang off after it's installed. We'll see more on that a little later in this video. They even ground the end of the insertion tool square so you can put it in a tap handle. You have to use a specific size drill with each of the thread sizes in these kits, and that's listed on the package, and it's also printed right on the tap. For our 3/8/16 threads, we need to use a 25/64 drill bit, and I have that here. We're actually taking out very little material, and I know some guys can do this with a hand drill, but that isn't me. I have no problem recognizing that my drill press is way more accurate than I am. After coring the hole to make sure there's no debris in that, I can use the included tap to start cutting the threads. These taps may be cutting special threads for these inserts, but you use them like anything else. Go a half to a 3/4 of a turn forward, and then back it up a half a turn or so to break the chips, and keep repeating that cycle. And as we did with the bolt, once we cut all the threads, I go ahead and spin this tab down and up a couple of times just to make sure we clean everything up real well. When we screw the insert onto the insertion tool, this cut engages the tang in the bottom of the insert. As the insertion tool pushes on that tang, it actually reduces the diameter of the coil a little bit and makes it go in very easily. We start feeding the insert into the threads in a hole just like you would a bolt. And we just carefully turn the insert until it sinks down into the hole. We want to turn the insert in until its top edge is below the top of the hole, just a little bit. When we back the insertion tool out, that releases the pressure on the insert and expands a little bit and fits into the threads very tightly. And now we have brand new 3/8 by 16 threads. Remember that little notch next to the tang? Well, that's how we get rid of the tang if we have a through bolt or we need to stack the inserts for a long threaded hole. I just set a good size hex key down a hole, set it on the tang, wrap it with the hammer, and it's gone. After knocking off that tang, we can thread one bolt through one insert or stack inserts in a deep hole to really grab a long bolt. Knowing how to safely repair threads can save you a lot of money and a lot of time and a lot of frustration.
I don't know about that ratchet handle.
I know, I didn't.
Seems a little.
Seems dangerous.
He must have a picture of those.
It's like the ratchet, the new Magnaflux we have has things like that. I don't like them.
Wait, so you said on the blind hole you just leave the tag there?
Yeah,
Okay.
yeah, or you can stack them. Yeah,
So we change aluminium to steel, so we should change torque of a bolt, right?
if you do what?
We're changing aluminium thread to steel thread.
Yeah.
So the torque will be different.
Nope, same torque. Okay, so for example, we're talking about a Lycoming engine that had a 1/4 inch bolt going into hold the case on, going into the aluminum case. The torque is 96 inch-pounds. So now I take out the aluminum threads, I put in steel threads. I'm using the same bolt, right? Still 96 inch-pounds.
It's still going into aluminum, but it's through the steel.
Yes, it's just.
Yeah, but thread for till the thread in aluminium will be one side bigger. Basically, you expand the steel bolt for one side.
Oops, I guess this is still running. What do you know? I thought I stopped it. We can just edit that out later, right?
Copyright.
What's that? Okay, talk about hardware. Hardware. That's my point 3 because I'm still with that. So classification. Classification. Or this is kind of goes along the line with the part number. So hardware. Hardware is usually classified as 1. AN. AN stands for?
Yeah.
Thank you for saying Army Navy. What does your book say?
Air Force Navy.
Air Force Navy. As long as they get Navy in there, I really don't care. However, I say Army Navy since the standard was developed before World War II and the Air Force was founded in 1947. So Air Force Navy or Army Navy. Like I said, as long as you get the Navy in there, it really doesn't matter. That's pretty much been phased out. Well, there's still some AN stuff. Did I go too fast?
Yeah.
We'll go back later. All right. 2. What came after AN? So they had AN, and they decided, well, maybe there was a controversy between the Army and the Air Force, and so they had a big committee meeting, and they decided they had to do away with AN, and so they came up with MS, which stands for Military Standard or military specification. And then I guess somebody got mad because it was too much military and they didn't like that, so they changed it to NAS, which is National Aircraft Standard. So I kind of, the way I sort of envision it, we had the Army Navy, so we could take apart and say, well, we have like a castellated nut, AN 320, and they, well, we can't have it be Army Navy anymore because the Coast Guard's getting left out, and that's not working for us. So we got to change it. Well, what are you going to change it to? Well, we'll call it MS. What's that? Well, that's military spec. All right, so we got a military spec. We had an AN 320. What do you want to call it now? I don't know. I don't want to do a lot of work, so let's just call it an MS 2320. Call it a day. So a lot of parts they did that. They just had an MS-20 on the front and left everything the same. And it's like, okay, well, there you go. That one didn't work out well.
Same
so.
thing with rivets too, right?
Yep, same thing with rivets. It used to be an AN-470. Well, what is it now? It's an MS-2470. Oh, that's totally different. Okay. Yeah. So, although I don't think there's an MS-2320. I should have picked a 365 or something. But anyway, then NAS came along and they said, well, we want to do it completely different. So none of the numbers match up. So a lot of the AN to MS is easy to transfer over. But once you get into NAS, it's like, where did you come up with that and why? So I don't love figuring out NAS. So B, what do I say? Mini parts. Maybe called by AN, MS, or NAS. And really, they're very, very similar. Like a flat washer. You can have AN, an MS, and an NAS. So it's just going to be kind of who you're working with, how old they are. I guess that's how you can tell how old somebody is. Just hand them apart. And if they say, oh, that's an AN, something, oh, you're old. So
It's like the easiest number though.
it is. Example. Example is a washer, which was an AN 960. Well, that was easy enough. I could remember that. But it's an NAS 1149. So I know it by an AN 960. You might learn it by an NAS 1149. Or you may learn it by an AN 960 because that's what I call it. All right, so let's talk about specific parts. And like I said, I'm not looking for you to necessarily memorize parts. You'll pick that up over the years, but you do have to understand, especially bolts, which thankfully have stayed the standard go-to a bolt. We call it a standard AN bolt. Has stayed pretty much that. So let's talk about bolts, parts of a bolt. So first thing you have is the overall length. Which the overall length is really not the overall length. It is the grip plus threads. There we go. So the overall length does not include the head. So it's really not the overall length, is it? So how much is the overall length? Well, it's the length minus the head. So, but it is the grip plus the length, plus the length. No, that doesn't work. Plus the threads. What does grip mean?
How much is going to hold on to?
The unthreaded portion.
Unthreaded portion. Well, let's go back to talking about. That's what I'm looking for. What?
The portion that's in contact with the material.
Yes, because we go back to talking about rivets. What's the formula for finding the length of a rivet? Oh, you're hoping I wouldn't ask.
Grip plus.
Grip plus
1.5
1.5D. Well, what is this grip?
That's the
Thickness of the
All the sheets put together. All right, so when we talk about bolting something together, guess what the grip is?
all the sheet.
This is where the sheet should be. Whatever you're bolting together should be in this grip range. Well, we might be ending this. Yeah, I know. Yeah, please. Pumpkin, would you stop messing with the lights?
Please start.
Okay.
Can you hear anything there, Kevin?
I can do that.
Yeah. Okay. So when you're bolting something together, as I mentioned the other day, the nice thing about most AN bolts is you don't have this really big selection of threads. Like you can go to the hardware store and you can get a bolt that's 6 inches long, and you may have threads on for an inch or 2 inch or 3 inches or all the way up to the head, right?
Yes.
Okay, it's not so in aviation. When you pick up an AN bolt, pretty much the length here of the thread, this threaded section, is always going to be, I'm going to say, I've never read this, but I just know from experience, big enough to put 1 to 4 washers, probably not 4, more like 1 to 2. And, 4 is in there. It's like, what's the max amount you can put? 4. So that's why I said 4.
That's the thin ones, probably.
Not necessarily. So 1 to 4 washers, and it will. Some of how many washers depend on how many thin ones you have. Plus a bolt. Plus a nut.
No.
That's it. You're not going to get any more than that. And the reason why is because, remember, aviation want things to be light. You don't want a bunch of extra stuff. But also, you don't want threads running up inside here where you're actually bolting something. Believe it or not, the absolute most stress on a bolt is right about there during this transition period. And so that gets in the whole bolting practices, which I think I cover on either later now or in engines if we get, I think, in torquing. But you want to make sure that you don't actually end up bolting something that's coming through this area right here, because that adds more stress to it. So anyway, my point is, you know what the grip is. The overall length is the grip plus the threads. The threads are almost always just big enough to accommodate the washer and nut. That's it. Okay.
Question.
Yes.
Will that, like, speaking of rivets, we have bearing and shear
Huh?
failures. If you don't get the correct grip, will that cause a shear or a bearing failure instead of a bearing failure than a shear failure? Or?
What's going to happen when you're talking about bolted stuff? So shear failures where the bolt's going to actually shear this way. The thing with, okay, so when you're talking about bolts and shear, you're usually going to put a very thin nut on it, and you don't torque them very much, okay? And the engineers figured out that that's okay, and there'd be applications where we're going to do something like that. If you're doing something in tension, you're going to use a taller nut, and the torque is higher. Now, here's the thing about that. So I know what you're kind of asking, how many, that goes more to how many bolts per inch, which we don't get into. I mean, it's pre-designed by the engineer. But what you have to know is the difference between a shear loading and a tension loading. Okay, so if you're doing a shear loading, you're usually going to use a thinner nut with a low torque. If you're doing something in a tension loading, it's critical that the torque that you are torquing the bolt to stretches the bolt enough to get enough preload on the bolt that the bolt is under more tension than is supplied by whatever's happening. I was just going to go there. So that's a perfect example. So for example, on an aircraft engine, we have studs sticking out of the crankcase and some through bolts that'll go through, right? And a nut that's going to go on there. So we have the head and the whole cylinder. What kind of stress is that under? Is it a shear loading or a tension? Okay, it's under tension. So every time the piston comes up to the top and it fires, it's going to drive the piston back. Or it's trying to drive the head that way. So it's under tremendous, I don't have the numbers in my head, it's in the thousands of PSI on the bolts, trying to shove it away, okay? If you don't torque that nut, okay, so getting ahead of yourself, when you talk about torquing a nut, you're talking about twisting, right? Okay, so it's like, how tight do you make it twisting? In a perfect world, the engineers would say, they don't care. You don't care about this twisting motion. That's just a twist. It means nothing. It's completely meaningless. What they're trying to say is how much you're stretching the bolt. So somebody has figured out if you put this much twist on it, it's tightening it to a point that it's pulling it X number of pounds. Really expensive bolts for rod nuts aren't even torqued. Yes, you tighten the nut, they're just leaving, but you use a micrometer and you measure the stretch. And so in a perfect world, you would actually measure every single bolt for stretch, but that requires precision grounding on both sides, and it doesn't work that way, so we just torque it. So, all right, so back to this head. If you don't put enough torque on it to properly stretch the bolt and put it under a preloaded tension, let's just say, I don't have the numbers in front of me, but I was trying to make up something in my head, something like 15,000 PSI or something. So let's just say, I'll just make up numbers. So let's just say that the bolt is trying to be ripped apart with 1,000 PSI, all right? If I torque the nut so there's 900 PSI on it, what happens every time the cylinder fires? It's going to stretch a little bit because there's that 1,000 or 100 PSI, whatever my numbers were, of stretch. It's going to stretch a little bit back, stretch a little bit back, stretch a little bit back. And that's going to work hard in the bolt until it just breaks off and falls in the cowling. And then when all 6 of them do that, then the cylinder goes that way. Right? So you have to preload it higher than the loading it's ever going to take. That way you've got 1,500 PSI and the cylinder's only got 1,000 PSI, and you got 500 PSI built into the bolt, and it never moves. It's there and it's solid. So that's good bolting practice, along with the fact that you don't want anything to end up split right there. As far as something that's under shear loading goes, really it's the strength of the bolt in this area right here. It's just the metallurgy of the bolt, and the nut is just there to keep the bolt from flying out, and the bolt is actually the rod that's keeping things from shearing. Hopefully that made sense to you.
So if it shears off, like on a rivet, it like takes off the head.
Yeah.
But like on the bolt, would the entire head of the bolt then just come off?
In a shear load, well, what you find is there's all kinds of metallurgy that is beyond what we're going to discuss. But you can see some of them neck down. They get smaller, then they break. But there's an entire lecture about just bolt analogy, metallurgy. What? What?
That was an example you have up there, neck down from the head.
Neck down from the head right there? All right. So where am I here? All right. I forgot about break. I'm sorry. Okay, break time.